All right, you guys, welcome back. In this section, we're going to be covering adding and subtracting radical expressions, okay? All right, so if you are trying to add and subtract radical expressions, they have to be like radicals. So in other words, the expression or the number under the radical sign, the radicand, must be the same. They must also have the same index. In this case, you're just going to add the coefficients, and if the expressions are not like radicals, you're going to have to simplify first and then subtract or add if possible. Okay, so we're going to do examples of both of these. We're going to add and subtract radicals that are like radicals first, and then I'm going to show you what's going to happen if they're not the same. Then we're going to convert them so that they are alike, so then we can combine them by adding and subtracting. Okay. All right, so this first set of examples tells us to add the radical expressions. Okay, so A says the square root of 7 plus 2 square root of 7 plus 9 square root of 7. Okay, so in order for radicals to be like, okay, so let's make this note over here. All right, in order for radicals to be like, okay, that means that the expression underneath the radical sign has to be the same, okay? And it means that their indexes have to be the same. So both of those have to be the same in order for you to add and subtract them. So let's look at what we have on this problem. So in this first problem A, let's look to see if all of our radicands are the same. So there's a 7 underneath the radical sign here, 7 underneath there, 7 underneath here. So all the radicands are the same. Now let's see if all of the indexes are the same. So here on this radical sign, you don't see a number there. It's understood to be 2, okay? So let me do that in another color for you guys. All right, let's see. All right, so this number here, there's no number there, so it's understood to be 2. There's no number here, it's understood to be 2. And there's no number here, it's understood to be 2. Okay, so because there's nothing there, they're understood to be 2. So that means that all of our radicands are the same, and so are all of our indexes. So in this case, we have like radicals, which means that we can add or subtract them. Okay, so when we add or subtract them, we're going to combine the coefficients that are on the outsides first. So here you don't see a number, it's understood to be 1. So we're going to add 1 plus 2 plus 9. So 1 plus 2 is 3, and 3 plus 9 is 12. We're going to keep the radical, which is square root, and put the radicand back, 7. So we have 12 on the square root of 7. Okay. All right, let's look at the second problem. So for B, all right, we're adding again. And in order to add radicals, their radicands have to be the same and their indexes have to be the same. So let's go through and check that. So let's see, we have 11x here, 11x there, and 11x here. So they're all the same. Now let's check to make sure that the indexes are the same. So we have 3, 3, and 3. So we're good. All of the indexes are same. All of the radicands are the same. So we can go ahead and combine them. So we're going to combine their coefficients first. So we have 4 plus 3 plus 24. So 4 plus 3 is 7, and 7 plus 24 is 31. So we have 31 cube root of 11x. And that's our answer. Okay. So let's move up. Let's see if we're right. Yep, 12 square root of 7, 31 cube root of 11x. Good. All right, now let's look at what do we do if the radicals we're adding and subtracting are not like radicals, okay? So if they're not like, that means that either their radicands aren't the same. We're going to look at that. So let's look at the first one. So we have the square root of 12 plus the square root of 27 plus the square root of 48, okay? So notice that even though their radicands are different, okay, their indexes are all the same. That's important. All right, so let's make a note of that. So if we don't have like radicals, we may have something that looks like this, where their radicands, all right, are different. But in this case, all of their indexes are the same. Okay, so let's practice working with these problems. All right, so since their indexes are the same, we don't have to do anything with the radicals, but we're going to have to simplify the radicants so that they match. So hopefully when we break them down, they do match. If not, we're not going to be able to combine them any farther than what they already are, okay? So when we're going to break down radicals, okay, we're going to break down the radicals into primes. So if you guys don't know what a prime number is a number that its only factors are 1 in itself, okay? So for example, 2, okay, would be a prime number because the only two numbers that can multiply together give you 2 are 1 and 2. So that would be an example of a prime number. So let's break down 12. So I could break down 12 in 2 times 6, okay? 2 is prime, 6 isn't. Numbers that are not prime, we call them composite. So we can continue to break down 6. We're going to do 2 times 3. So now we have all prime numbers, okay? Now, when we have this radical here, so let me change the color, all right? There's understood to be a 2 here. So when you think about simplifying the radical, you want to pull out these prime numbers in pairs of 2s. That's how they can come out because that's what our index is. So if I'm looking at my 2s here, I have a pair of 2s, and the 3 doesn't have a pair. So that means the 3 cannot come out of the radical. It has to stay underneath. So when I simplify this, this is the same as 2 will come out, square root of 3, okay? Now I'm going to go to simplify the next one. So 27. 27 can be broken down as 3 times 9, and 9 can be broken down as 3 times 3, okay? So we're going to look at the radical again. The index on here is 2, which means that items can come out of the radical as long as they come out in pairs, okay? So we have a pair of 3s here. This last 3 doesn't have a partner, so it's not going to be able to come out of the radical. It's going to have to stay underneath. So we have 3 square root of 3. All right, let's break down the next one. All right, 48 is the same thing as 2 times 24. 24 is the same thing as 2 times 12. Let's make that a little better. 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. All right, so just like the other ones, we're dealing with a square root, so the index is 2, which means that our prime numbers can come out in pairs. So we have a pair of 2s here, pair of 2s here, and this 3 doesn't have a partner, so it has to stay underneath. Now for this one, we have 2 sets of pairs, okay? So when you pull them out, you're going to multiply the sets together. So 2 times 2 is 4 square root of 3, okay? Now that we've simplified all of these, okay, now we can combine them. So their indexes are the same now, and their radicands are the same. So we're going to combine their coefficients. So 2 plus 3 is 5, and 5 plus 4 is 9. Square root of 3. Okay, that's going to be our answer. All right, let's look at the second one. So for the second one, we have the cube root of 8p to the 4th plus the cube root of 125p. Okay, so we're going to break those down just like we did for the problem above. So I know I have to break it down because remember, in order to add or subtract radicals, they have to be like. So in this problem, the indexes are the same. They're both cube roots, okay, but their radicands are not the same. So we can't combine them the way that they are. So we're going to have to break them down into primes, okay? So let's break down 8. So 8 is the same thing as 2 times 4. 4 is 2 times 2. All right, so this time, because our indexes on these are 3s, when we pull them out of the radical, we're going to have to pull out groups of 3. So every time that indexes change, in order for things to pull out, you have to pull out the same amount as what the index is on your problem, okay? So lucky for us, we have 3 2s. So 2 gets to come out, okay? So we're going to write, change the color. All right, we have 2. All right, now we're going to look at the variable. So remember when we simplified these before, when you look at the index and you look at the power that's on your variable, you want to ask yourself, how many times can 3 go into 4? This time, 3 can go into 4 once, so I'm going to pull out 1p. cube root. And then 3 goes into 4 one time, but it also has a remainder of 1, so 1p stays on the inside. Okay. All right, we're going to simplify the second one. So 125 can be broken down as 5 times 25, and 25 can be broken down into 5 times 5. So that index is a 3, which means that things have to come out in groups of 3. I have 3 5s. So I'm going to write that. Plus 5 cube root. All right, now we're going to look at the variable. So 3, this is understood to be 1. Remember, anytime you don't see an exponent, it's understood to be 1. 3 does not evenly divide into 1. You don't have enough of those p's to come out of the radical, so it's going to have to stay underneath. Okay? So now that we have the same radical, and we have the same index, and we have the same radicand, we can combine them. Okay, so we're going to have 2p plus 5 times the cube root of p. All right, that's our answer. All right, let's look at C. All right, for C, we have the square root of 50 plus the square root of 15. Okay, remember, in order to add or subtract radicals, their indexes and their radicands have to be the same. So for us, their radicands are not the same, but their indexes are. They're both 2. Remember, if you don't see a number that sits on that hook part of the radical sign, it's understood to be a 2. So we're going to need to break down those numbers into primes. So 50 can be broken down into 5 times 10, and 10 is 5 times 2, and 15 is 3 times 5. All right, so let's see if we can pull anything out. So in this first radical, all right, we have a pair of 5s that can come out. 2 doesn't have a partner, so it's going to have to stay underneath. And for the second one, you have 3 and 5. Nobody has a pair here, so nobody can come out of the radical. So when we go to write this answer, we're going to say it's 5 square root of 2 plus, we can leave the second one as a square root of 15 because nothing's simplified out, okay? So this is going to be our final answer. Right? So don't think every time you simplify these radicals that they're going to combine. Sometimes they won't. Just you always have to simplify. When you simplify, sometimes they combine. When you reduce it, sometimes they don't. So you just have to be prepared for the problem. All right? Cool.